Hello, everyone, and welcome. Welcome to the Women in Security Elastic Summit 2023. This is our second annual Women in Security Elastic Summit. My name is Tanisha L. Turner, and today the talk that I will be delivering is Journey into Malware Analysis and Reverse Engineering. This is my journey. This is my journey into malware analysis and reverse engineering. And without further ado, I'm going to go ahead and present. And for those of you who don't know me, about my background, I have extensive experience in malware analysis, threat identification, reverse engineering, and security operations. Here's a brief summary about me and my interests, and some of the activities that I participate in the community. I am very active in the community, where I have done a lot of speaking engagements with ISSA, with RSAC podcasts. So there's a lot of activity that I do participate in a community, and please feel free to follow me on LinkedIn, X, formerly known as Twitter, Mastodon, and Mastodon. And I'm CyberSec Diva on all of these. And I also have a malware analysis and reverse engineering. I have an introductory series. It's on Vimeo, so feel free to check it out. And it's also will be on my LinkedIn page as well, so feel free to check it out. And let's talk about my journey. My journey was a unique journey. It was a unique journey to get from IT to malware analysis to doing research and reverse engineering. My journey started with in 2008 when I developed an interest in C programming languages and assembly language. These are two topics in which I did unlearn and I developed an interest into, which when I was taking a college course. I'll be honest, my first experience with assembly language was a love-hate experience. I did not like assembly at all. It was one of those to where I didn't understand it in the beginning. So I was not always really great at assembly. I didn't understand the concepts, and I didn't understand it. Why do you have to provide so many instructions instead of it having the same capacity as a compiler? So that was something that I didn't have an interest in. From there, I started learning Linux and Python, which that is where I developed an interest into the security part, because with Linux, I'm learning the command line and doing a lot of Linux hardening and configuration of the firewalls. That is where I developed an interest in security, and it went from there. From there, you may wonder, how did I go from learning Metasploit to transition into malware? Metasploit, as some of you are aware and familiar with the tool, it is a pen testing tool. But with Metasploit, you do get a chance to look at vulnerability assessments, and with Metasploit and looking at the metadata of these vulnerabilities, that's piqued my interest into, okay, what does this do behind the scenes? What do these exploits do it, and how can I see as far as how are they structured? And from there, that's what pivoted my way into becoming a malware researcher. Let's talk about malware research. Before you start to do any type of malware analysis or malware research, you have to know the different types of malware, which is malware identification, and you have to know what each malware does and what their function is. And these are some of various types of malware that there are. There are a lot of different ones, but these are some of the more common malware that you may see. And this what I'm showing you is an example of static analysis. This is used on a tool called Detected Easy. which Detected Easy is a tool that can analyze malware. And what you're seeing now is from a signature from GAFI malware signature. That this is what you're seeing, and this particular file is an F file, and that's an extended link file. That's a Linux file, and that's in. And what we're seeing right here is where it's showing the type of file this signature, this malware signature is, and then you can, and as you can see here, it also shows you the hex part of this, and what the hex part of this, and what that is a packer. When you see in the symbols, it shows F, which that's identifies a packer. Packer is where malware tries to hide itself and hide itself into hidden view into the language. And as you can see, it shows you a type. It shows you the file type, which is it's a 64-bit, and it shows you the architecture, which is AMD 64. And I'll let you all know that I'll go into more of a deep dive and explain how I got this and the steps I measure. But I will not do this on this session, because this session I want it to be more friendly for both non-technical and technical audience. But I want to show you exactly when you're doing malware research, this is something that you will see when you go into static analysis. And here's some learning tips I want to give you about learning malware analysis. First of all, before you do any type of malware analysis, and you have to build your sandbox environment. And you can build a sandbox environment through various ways, whether you want to do it through virtual machines, or you can do it through containers. I highly recommend using virtual machines, and there's different types of virtual machines that you can use to host a malware environment, where you can have a sandbox environment. Another step after this, and these are techniques that have helped me in my journey in malware analysis, is you retrieve the malware samples. There are a lot of resources out there, on free resources out there, as far as where you can extract malware samples, and I will be showing you some of those towards the end, and providing you with those at this for the sites. And you can also watch this back, and you can see the different resources where you can get free malware samples. Your next step after you retrieve these samples is, when you go to analyze this malware, you need to choose a malware analysis tool, to where I say use one to where when you're starting to analyze malware, use a malware analysis tool that's user friendly. And my preference for the malware analysis tools for any beginner is Remnux is one. Remnux, it has a lot of tools in it. It even has Gidra, which is a reverse engineering tool. It has Cutter. It has Detected Easy, which is the last slide that I had showed you, that where it showed the static analysis of the malware signature. So I recommend Remnux. I recommend you getting a comprehensive tool that has a lot of the different tools on it to where you don't have to download each tool and analyze malware. The last step when you're analyzing malware is you need to document your findings. When I'm saying when you document your findings is as you're analyzing these samples, and as you analyze the samples, then you need to capture the behavior. Capture behavior, whether it's static analysis, which is a malware that is not executing in real time, whether it's dynamic. Dynamic is when malware is executing in real time, and you're actually observing the behavior. And when we go, and then you can even capture what is hybrid analysis. Hybrid is when you're looking at malware from both the static and a dynamic perspective. So it's very important to where you can capture and record your findings. And when you do this, if you're doing it on a virtual machine, if your virtual machine has the capacity to take a snapshot, that is something that you probably an option that you want to consider, because when you're taking snapshots, a snapshot, you can save that particular malware behavior for later on, just in case you want to document and go back and look at your findings. And also another reason to take a snapshot is is any type of malware that you may download and extract. A lot of times malware will is tricky. After it's execute, a lot of times malware will try to hide itself, and you may not even see the type of behavior that you've seen before. Now, I want to touch on topics reverse engineering, and as I said, I will not go into a really deep dive. The deep dive that I will be covering, it will be in my sessions, in my content sessions with my series, Intro to Malware Analysis and Reverse Engineering. I will go through step by step on reverse engineering, and I will go step by step on how you can reverse engineer malware samples step by step, and I will cover assembly language and YAR rules. But for all intents and purposes, I want to give you an introductory and an overview just to get you started, but you will see more in-depth coverage in my series. A lot of people may not know what is reverse engineering. Reverse engineering of software. In software engineering, reverse engineering is deconstruction of code or binary code and recreating it back to the stack trace to identify the source in structure. So anytime you think about this, anytime we're doing any type of malware and reverse engineering, that's what we're doing. We want to deconstruct it. We want to see how that malware is structured. We want to see what it's made up of. We want to see the components of the malware. So that's what we're doing when we're doing any type of reverse engineering. And that's whether we're software engineer or whether you're reverse engineering malware. Okay. This is an example that I'm showing you here. This is using Ghidra, which is an excellent tool. Ghidra is a reverse engineering tool, and I analyzed this malware signature called GAFGuide. I've analyzed this one using Ghidra, and this GAFGuide is one that has a type of malware that has been used botnets, and it's affected a lot of IoT devices. So this is one to where it shows the hash of this malware, which is hash signature, which is SHA-256. And on this, as you can see with this particular dissembler example, you can see on here, you can see some of the assembly language on here. You can also see on this particular one, you can see where it shows on the stack, and if you see here, right here, and it push, push is where anytime you push anything on the stack, I mean, that's pushing it on memory location. That's pushing it on top of the memory location. And this is a way that I tell anybody who's learning any type of assembly or reverse engineering, last thing pushed on the stack is the first thing popped. So when you see in assembly code the push and the pop, think about it this way. The last thing I'm pushing to the stack is the first thing that is going to pop out. So pushing it down, it's going to pop. So I push it and push it down, pop. That's retrieving. And what we're doing is we're retrieving the contents. We're retrieving the memory location. So that's what we're doing when we're talking about the push and the pop. So when you see that's just something that can give you a little hints and suggestions when you're learning, as you learn in assembly. And assemblies can be tricky now. Like I will tell you, I was not always advanced with assembly. I did not like it at first. I said, what was the purpose of this? I can just run a program and see. This is ridiculous. But now I really love assembly, and I have a passion for it. So I can talk about it all day long, but for all intents and purposes, I'll cover that in my series in the future content. What I want to show you is show you more of a concrete view of the disassembled view of this particular signature. The reason why I want to show you this is that as you can see, and this is using Ghidra. This is using Ghidra, which is the rev tool. We call it RE, which is reverse engineering. So anytime you see that type of jargon, that's reverse engineering. Sometimes researchers like myself and others, we just shorten it and we just say RE. That's what we usually do. But this will show you here, and when you're looking at this disassembled view of this signature, this shows you, hey, this is it's an F file, and it shows you here when you see sub RSP. When you see sub RSP, that is that's assembly instruction. Sub meaning subtract. RSP in R, anything with R in front of it, in assembly language, that's part of the x86 architecture. That's what that is. So anytime you see with the R, you know it's x86-64 architecture. So in this particular one, then this is what this is. We already saw that it was AMD x86. So, and we see this is a RSP. So RSP meaning is the x86-64 architecture, and SP is the stack pointer. But when you go into assembly, and I'll provide you some resources, you'll learn all these different registers, and that's what that is. RSP is the stack pointer on an x86-64 architecture. And this particular signature is part of that architecture. So that's what this is, something I wanted to show you that's in full view, so you can get more of a concrete look on what capacities and functionalities that Ghidra can provide you. Here's some tips on learning reverse engineering. And as a new researcher, when you start learning malware analysis and reverse engineer, it can be sometimes overwhelming and tricky. But I tell anyone this is, you need to start off with the basics. Start off with the basics of learning the reverse engineering terminology. That's very important. And another thing that you need to do, and this is for any new researchers, is that you need to find a tool that has a great user-friendly environment. A lot of tools out there are on command line. I'm a command line person, and I can easily navigate through them. But when you're a new researcher, then you want something that's more user-friendly. So I honestly I highly recommend using one with a nice GUI environment like Cutter. Cutter is one that is a good reverse engineering tool, and I'll show you an example of what Cutter looks like too after you disassemble that particular signature. And I'm using the same signature as we go through this session. And Ghidra, we just saw a couple examples of what Ghidra looks like after it's analyzing a sample. So those are the two that I believe are very user friendly. And you can find those tools on the Remnux environment. So you don't have to download separate tools. That's why I'm a big component of tools that are comprehensive. So these are the ones that those are the two I highly recommend. Another thing that I highly recommend is that you create a reverse engineering cheat sheet. And when I say about creating a cheat sheet, that means that's helping you learn better. That's helping you learn any of these new terms and terminology. So I highly recommend you create a cheat sheet. And as always, with any type of new concept, you need to document your findings, and you need to generate a report. And the reason why I say to generate a report is because once you go back and look at your findings, then you can put all of it together, and it all comes together in a comprehensive manner. So that's why it is important that you create and generate a report and document all your findings, and that helps you to learn too. Like I said, we're not going to get into that deep into assembly language, but this is assembly language is a low level language, that interfaces with the computer architecture, and it uses a set of instructions. Now, when you're using assembly language, then in order to execute that low level code, you have to have an assembler. There's a lot of different types of assemblers that are out there, but I would go over a couple of them for you. But it's very important that you choose an assembler that is easier to use. Now from Microsoft does have one called the Microsoft Macro Assembler tool. So that's one that's used for Windows environment. This is an example of what I'm showing you here is an example of what Cutter looks like when disassemble that malware signature. That malware signature that we've been using throughout is GAFGuide malware signature. So this is what Cutter is looking like. Cutter looks like disassembling this sample. and 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 this shows you how it looks in a sim language. So when I brought up this signature here, as soon as I brought this signature here, I could trace through it through Cutter. This Cutter, if you see where it starts off here, it's adding the bytes. I mean, and you see where it's adding the bytes to that RAX register, which is a when you see AX, that's the accumulator counter. So anytime you see AX in the registers with assembly, that is part of a counter, an accumulator. So that's what that is in registers. I wanted to show you this too, because as you can see with Cutter, you can, and this particular view is showing you all the different registers, for this particular sample. And when I was doing this live, I'm tracing through, I could trace through each set of instructions. Like, I mean, remember I was talking about the push? Now this is pushing RBP. RBP is a register. Now that's the base pointer. So I'm pushing that on top of the stack. And then that's pushing on top of the stack to that memory location. And then when I move to this, it's RSP, which is stack pointer, BP, which is the base pointer. So when you see this particular format in assembler, like anything that's on the right hand side here, any registers on the right hand side, you're moving that into that register. So you're actually in assembler, you're going from right to left. So with this one, this MOV is moved. So you're moving RSP into that RBP register. So you're moving this stack pointer into that base pointer register. So that's what that is in assembly, if you see that. And the tips for learning assembly, like I said, there are a lot of different tips for learning assembly language, but the most important tip I have for anyone that's learning assembly is to learn a basic terminology of assembly. Assembly can be tricky, so I just say start off easy with learning the terminology of assembly, and you need to understand what the registers are. There are a lot of different registers in assembly, so you need to understand that. You need to understand what stack pointers are. You need to understand what the assembly's instructions are and how they interact once you with the language. Another component I tell people, just as with the other topics, is that you need to create a cheat sheet. And with assembly, it's very helpful with assembly when you create a cheat sheet, because with assembly language, when you're trying to memorize all those different registers, if you have a cheat sheet, then you can always reference it, and you can't memorize all of them. And last but not least, when you want, after you follow these steps, and these are steps that have helped me, then you can actually create a simple assembly language program. And I say start off with the typical program that everyone starts off with, which is Hello World. That's to start off with a simple Hello World program. And you can do that once you start off with that Hello World program. There's also online assemblers that you can load the assembly instructions into. But I prefer using either some of these assemblers. Now there's NetWide assembler, that's part of the BSD. That's used on BSD, Linux BSD platforms. Then you have Microsoft Macro Assembler. And then you have the Goonie assembler project, which is also called GAS. So any of these are good tech tools to use for assembler to execute your assembler code. But there's also tools online that you don't even have to download these tools. You can also load any of your basic instructions online assemblers to learn that. Now, and with that being said, I touched on some of the basis of my journey into malware analysis and reverse engineering. So everything I shared with you were tips that helped me and how I started my journey, and how I'm in my journey now to where I love this reverse engineering and becoming a researcher. So with that, I want to open up the floor for any questions, and my moderators are looking at the chat on any questions that anyone has. And I want to say thank you to everyone who's joining live or who will watch the recording. So does anyone have any questions about any of the content they've seen so far? I'm looking at my moderator chat. So I'm still looking at the chat. So okay. Okay. Someone asked a question that you mentioned that you were releasing a reverse engineering course. How can we access this? When good question. Any of the courses that I release, which are all free, any of the courses I which will all free, and they're all user friendly. They're introductory beginner courses. I don't expect you to know any of it, so it's good. It's kind of as if you don't have any knowledge. Then you can access these on Vimeo. Any of the courses that any of the content that I have, you can access it on Vimeo. And then I usually will share it. I usually will tweet it out, or I will share it on any of the other social media platforms. Okay. And another question someone asked, what are some recommended tutorials for books or for learning assembly? Good question. Now here's some resources that I like for as far as what helped me. Now, Azara Labs. Now, Azara Labs is a security. She's a security influencer, and she's usually on Twitter. Now, she has really good content. There's a lot of different tutorials out there, but the reason why I like Azara Labs in particular is because she has both for assembly and reverse engineering, and she has cheat sheets, and she has and hers is very user friendly, and it's for beginners. So that's who I recommend. And there is one also that I didn't put on here. There's a tutorial point. Tutorial point is another one that you can learn for assembly. Is tutorial point, and they're very user friendly. They're even user friendly with languages such as Python. Let's see, somebody else had a question, and bear with me. I'm reading these from my moderators. Okay. Good questions. Somebody asked about some tips on using debuggers. Well, with unpacking and using debuggers. Well, with that, I'll cover a lot of that more in depth. But really, with unpacking any of these, it's really going to take time to learn and be able to read any of these with unpacking debuggers. That's why I really strongly recommend anyone that's new to doing this to get a user-friendly GUI analysis tool, especially with debuggers, and then you can go from there. But I'll touch more on basis with that in my content, but it really takes time. It's not something that because it's not something that you're going to be able to, even when you analyze a sample, for instance, even when you're debugging. There's been times where, even as experienced researcher, that I've debugged something and it doesn't come out the way I want, but a lot of times I'll have to even dig deep, and then finally I will get the results I want. Let's see, there's any other questions? Okay. Okay, what would you say was the most challenging aspect of learning within your career as a malware researcher? Good question. The most challenging aspect of learning was, again, I'll go back. I have this love-hate relationship with assembly. I did not like it at first. I wanted assembly to work like C. I wanted assembly to work like every other language, but I did not like assembly. So that was my most challenging one. Is assembly, because I felt like it was doing opposite. That the only other challenge I had initially was was when I first analyzed the sample and I didn't get the results I wanted. But then I remembered, okay, well, if I'm looking at something dynamically, if I'm looking at something dynamically in real code, then hey, a lot of malware, if it can tell when it's in a sandbox environment. And see, me as when I was a new researcher, I didn't know that malware can even identify that it can be if you're in a hosted machine or in sandbox, and it can conceal itself. So I didn't even realize that. So that was something that was something I had to learn as a researcher, that there's got to be a better ways of where you can identify malware without it when it conceals itself. Are there any more questions? Okay. With that being said, everyone, as we close this session out, it's 11:30. I want to thank you everyone for joining the session. I want to thank you to all who whether you're joining live or whether you're watching a recording. I want to say thank you so much, and I want to thank you to my moderators. I'm Caitlin Boyce, Corey Mangini, who's co-host, and Saman College. I want to thank you for helping host and co-host and moderate this session. So thank you, everyone, and everyone. You have a wonderful day, and please follow me for future content. And coming soon, I promise, coming soon, future content, and I'll get more in depth on these topics, and we'll go step by step, and you'll see all this in real time, me analyzing samples. Good night and good day, everyone. Thank you for watching. Goodbye.